Good evening, everybody. I'm Darshan and I'll be your host for the evening. I would like to welcome you all to the Electronics Summer Internship Program Preparation and FAQ on behalf of SARC. This talk is part of an ongoing effort to provide clarity and guidance regarding the Summer Internship Program or the SIP. This discussion is especially crucial for first year students who are exploring their interests in the electronics domain and might be unsure, overwhelmed, or just starting to think about how to secure meaningful summer internships in this field. Today, we are joined by Ashmita Mukherjee, a third year ECE student who secured an analog internship role at Texas Instruments, Manashwi, a third year EEE student who secured a digital internship role at Texas Instruments, and Shivansh Verma, a third year ECE student and upcoming hardware intern at Google Hardware. Together, these seniors will be sharing their experiences and insights to help you better understand the landscape of electronics internships. Through this session, you'll gain valuable knowledge about the application process, preparation strategies, and the different roles available, all aimed at helping you make more informed decisions as you begin your own SIP journey. So, without further ado, let's dive right in. Each of our speakers will now take a few minutes to walk you through their journey, starting with Ashmita.
Hey, am I audible?
Yes, you're audible.
Okay, just give me a second. Can you see my screen?
Yes, your screen is visible.
Okay, sure. Okay, so hi everybody, I'm Asmita, and I will be trying to give you some insights on how the OA and interview process is going to be for the analog role in TI. So I'll walk you through the courses to prepare, resume building, importance of SOPs, importance of CGPA, and my SIP experience. Okay. So before I start, I would like to just touch upon the difficulty of the OA and the interview questions. The OA has two parts, the aptitude section and the analog section. The analog section is completely formula-based and extremely easy when compared to the exams that you give for your courses, like your quizzes and midterms and stuff. The aptitude section is really what holds you back because there are many questions and it is difficult to solve all of them in the given time. So I recommend that you give many aptitude tests, mock aptitude tests to increase your speed. The interview is a different thing altogether. Here, they do not care about your how many formulas you remember and how accurately you can solve a problem. They mostly are concerned about how much knowledge you have about a given topic, like how well you know your circuits, like how do you know how a capacitor functions, how a resistor works, how do these elements work, how a MOSFET is made, like how a channel is formed in a MOSFET. They don't care if you can identify what a common drain is, what a common gate is. They want to know if you actually understand how that particular device is made and how it actually works in practice. So that is what is very important. So you need to have a very in-depth understanding of that. So for courses to prepare, the most important course is ES. So you really need to have a very good understanding about RLC circuits. I think 70% of the questions, both in the OA as well as the interview, are from RLC circuits only. So you really need to have a very good understanding of how circuits function. And by circuit functioning, I do not mean formula-based circuits. What I mean is, if somebody tells you that I give you an input, a pulse, how will the output look across a capacitor? And you need to know all of this without like solving it on pen and paper. You need to just be able to intuitively tell all this. So that is very important. ED mein, it is not that important of a course, especially the pre-midsem part, but post-midsem, again, devices are very important, like MOSFETs, BJTs. One of my questions was from there only, the difference between MOSFETs and BJTs on an intuitive and physical level, not like formula-based level. MUI, I assume you don't have to revise it because you've just done it. So I think class notes are enough, and you need to know how it works. You don't have to go into depths of like frequency response and stuff. They don't ask all that. So apart from that, like all of this is not very important, but Laplace transforms, Bode plots, and op-amps. Op-amps is slightly important, but I assume you've done it in ES, and they ask very basic questions about how op-amps like work and stuff, and like you can like solve it even without knowing how op-amps work. It's basic Thevenin, Norton, and all of that. So here I've attached all materials. I suggest that if for like practicing questions for your OA, you need to just do PYQs of your own like quizzes, midterms, and compres. That's enough, and it's because the questions that you have already attempted in your quizzes and stuff are like much harder. So like if you can solve those questions, the questions in your OA will be a piece of cake, and you can just go through them very quickly, and you will be more accurate as well. So I suggest you don't have to look into multiple resources, just do your own PYQs, and you can just go through these links. I think one of them has like PYQs of interview questions also, and like OAs, so you can just watch all of this. Resume building is again another very important thing. One of the most important things about a resume is that you should not fake it. Many people think that they are falling behind because they have only one project or like a very underwhelming resume, and they try to add unwanted, unnecessary projects that they have no idea about. And this has actually happened in the past. And then you will be quizzed on your resume. They will ask you questions about your resume, and if they ask, and you need to know all the topics that you've written in your resume very well. So imagine if they ask you something, and if you're not able to answer it, and especially if it belongs to your project, that is like pretty bad. So you need just it's okay if you don't have very a lot of projects, but you need to have very crisp descriptions about the project that you've done, and it should be very relevant to the role that you're applying for. And most importantly, it should be legitimate. Just don't add it for the sake of adding it. I suggest, because resumes are slightly confusing because most of us are doing it for the first time, I just asked my seniors to send over their resume so that I could look at it as a reference, and I kind of recommend you do the same so that you have an idea of how to like go about it. You can add extracurricular activities as well, and I suggest you run your resumes through ATS checkers so that if there are any spelling mistakes and stuff, and it can get automatically corrected, and also you can get an idea of how good your resume is. Importance of projects, I think SOPs are pretty important, and it played a very important role in helping me get my project, my SIP, because, and also I think it's a good way to like make the interviewers focus on your project, because they tend to like, if they get interested in your project, they tend to like ask you more questions about it, and if you're able to answer it, it's a pretty good plus point. So yeah, a relevant project is definitely very important. A project relevant to the topic that you're in, to the role that you're interviewing for. So for example, if you're interviewing for an analog role, it's good if you have an analog project. It doesn't matter how many IT projects you have. CGPA is pretty unimportant as long as you qualify for the examination. That is good enough. You don't have to worry about the fact that you're not 9-pointer or whatever. It doesn't really matter at all, actually. So currently, I'm working as a validation engineer. None of this probably makes sense. It doesn't make sense to me as well because I have just started. But yeah, most of my work is lab based, and it is very related to the courses. So like I, on a daily basis, look at resistors, op amps, and capacitors while trying to figure out what to do. So yeah, you will be using your courses that you've studied in the college in your work as well. So thanks, all the best for your SIPs, and if you have any doubts, feel free to reach out to me. Okay. So I think Manash, we can continue.
All right. Hello, everyone. Am I audible?
Yes, you're audible.
All right. Just a second. Let me present. You can see the slides.
Yes, we can see the slides.
Okay. So hello, everyone. I'm Manashri. I'll be talking about the digital. So the process for the OA and was pretty similar as what Asmita said. The OA would be much easier than you are expected to see in your evals. So the main thing is how first of all you have to clear the OA and an interview they will grill you on the basis of your concepts. So first I'll be talking about what are the courses you need to prepare. So obviously no doubt DD is something which is really important and majority of your like evaluation would be done on your digital design concepts. Morris Mano is going to be your Bible. So just do all your basic concepts from digital of DD. The second thing is Verilog. I know a lot of you might not be having a good strong command on Verilog right now. So use this 2 months. I have also tagged one of the playlists, which is then my next slide. So you can do that course from NPTEL, I guess, and do your Verilog really good. It is really, really very important. Like maybe your first question in an interview will start from a Verilog question that the interviewer might give you. There's also this websites called Chip Verify and HDL Bits where you can, it's basically a lead code for us electronics people. You will have questions solving practice in that. The second is Compark and MUPI. MUPI is sufficient what you did in your coursework. So just revise that again. Compark, I know you guys have not done a formal coursework of it, but you are expected to know the core concepts like pipelining, cache, memory. So it's important to know. They won't be expecting like you to know entire detail में everything. Just definition wise or basically how things work, why things happen like that is more than sufficient. And there are some extra miscellaneous topics like SG analysis, which is a part of ADVD. So I saw someone in the chat ask regarding ADVD. So yeah, this is a topic from ADVD, which is asked SG analysis. So there's this website called VLSI Expert. You can like read from it, do some basic questions. Again, in-depth knowledge is not required, but I just don't know this concept entirely won't work. So you just have to know what exactly like definition wise things are. Second, focus on a C programming. CP में जितना करा था that's fine. उतना ही it's enough. RLC circuits may or may not be asked. Like OM में there is one question may be asked. An interview some people get the question, some people don't. Like for me, RLC wasn't asked, but for me, some fellow peers, it was asked. So just brush it up. It's to be on the safer side. So this is the materials ka list. You guys can take a screenshot of this and फिर Google Lens से निकाल लेना websites. I'll just skip it slide for a couple of minutes. You guys can take a screenshot of it. All right, I'll move further then. So resume building is actually really important because it's you guys have a short resume shortlisting round. So it will set you apart on the initial scale. First, don't just dump information. I know you'll be thinking ki this thing is important, this achievement is important, I should include, but don't. Like it's really important to keep your resume crisp. No one will have complete look on a resume. Like one page resume is very good. It's maximum. Second, tailor each section. So based on your so when I don't know if you guys have seen your superset yet or not, but when you will, there's a section for adding your courses. So add the courses in the order of your confidence. Like if you're more confident in UP, add UP before DD and like that. And also don't add random like projects. Like if you're applying for DD ka role and you have done some UI UX ka project, so it does not make sense to include in that. So don't do that. Third, highlight the tools and languages. So whatever, if you have done some projects and you use some softwares like Vivado or any software or some programming languages, do add them, because the skill sets will be like really setting you apart. But make sure you don't add something that you are not confident enough. Yeah, बस ऐसे लिखने के लिए लिख दिया है. Because you have to be confident in whatever you have written. See, interviewer has completely rights to ask you everything that you have written in your resume. You cannot afford to just fumble on a topic that you yourself claimed in your resume. So please don't do that. Just be sure of every single thing. If in a project there was some minute thing also that you did, make sure you know why this was done, why you took that kind of method for it or anything. So just be sure. Lastly, get feedback before sending. Everyone puts their like best efforts for the resume, but still things sometimes you might mess up something or it could be improved. So just get it proofread by your seniors, by your peers, anyone. They might see something that you missed. So yeah. Next, the important of projects. So they're really, really important. If you have done any project last sem formally, it's good. If you haven't, use this 2 months, do some good projects, because see, in an interview you have just 40 minutes to 50 minutes to impress your interviewer, and it's very important to get a chance to speak on stuff that you know, basically navigating your interview yourself. So projects will really help in that case, and of course resume building will also become strong in that. Last, CGPA, it doesn't really important. It just a qualification metric. अगर तुम qualify हो रहे हो OA के लिए, that's the most. Never for God's sake like weigh your odds based on your CGPA. कि I have seen many people like just thinking कि CG कम है, so हमारा तो क्या ही होगा. ऐसा नहीं है. You might see a 9 pointer not getting through, but a 7 pointer, 6 pointer getting through. So CGPA does not really showcase what you are. Just put your efforts in these 2 months and you can crack it. Lastly, my experience right now, I'm a design verification engineer. So my work mostly is for using System Verilog and UVM frameworks. Most jobs in India for digital role are for DV, and it's a really interesting job. I'm telling you, I have just been 1 week, majorly last 2-3 days of looking at what DV is actually. It's really good. So it's really worth it. Put your efforts. It's really nice. All the best to all of you. Now I guess Shivansh will continue.
Yeah. Hello, am I audible?
You're audible.
Yeah, let me just share my screen real quick. Yeah. So, hi everyone. I'm Shivansh. Manaswi has mostly covered everything I want to talk about in digital. I'll just go through the slides once and add whatever I want to add. And please feel free to keep asking questions in the group chat. We'll go over through them once or later. Yeah. So, hi. So currently I'm in Google Hardware and I'm in the Design for Test team, which basically works at including some circuits in the circuit itself before which we can use after fabrication to test that the circuit works correctly. So yeah, courses like obviously digital design is important. I think Manaswi has covered everything here that I wanted to talk about. Yeah. Yeah, that's correct. On ST analysis, you can also use any videos on YouTube. By the way, I think Pethe sir has a playlist on his channel. Like the last 3 or 4 videos talk about STA. If you want, you can refer to those videos as well. I found them really useful. For Verilog, yeah, HDL bits is really a good resource. For Verilog, I would also say like please, there's this one specific thing in Verilog that I want to point out, that you should be really comfortable with using smaller blocks to build bigger blocks. Like that is something that's straight out of my interview. Like for example, you should know how to make a shift register using a block of a D flip-flop or something like that. That's something you should know. Yeah. Compact is important, but again, your interviewers, you can let them know at the start of the interview that you haven't formally done coursework for a specific course and you've only studied this much, and they'll keep that in mind. That is something you can point out at the start. But yes, pipelining, cache, and memory hierarchy are very important, especially memory hierarchy. Caches can get technical. That's not something I think you can just do like on your own. Like, I mean, you can do it on your own, but like to really ask good questions on caches, you kind of need some technical training, I think. Like it needs to be taught to you as a course. But like, yes, the introduction of caches is important. Like you can use, I think, NESO Academy's videos to like just get like a top level view, like of why caches are required, what a cache hit is, what a cache miss is, what a L1, L2, L3 cache is. Again, that comes as a part of memory hierarchy, so you can look that up. Pipelining is important, and pipelining you can understand without doing comparc. Actually, like you can just read up on it, look at a few YouTube videos, and I think that can help you solve questions, help you answer questions on pipelining. Yeah, yeah, I think that's like covers it for courses. Materials is I don't have anything to add to this. Gate, I really stress on using gate PYQs because they really mirror the questions you'll get in OAs. Because gate again is an objective base. It is an objective paper, I think, and you have to answer A, B, C, D. So yeah, please use gate previous year questions, because some of the time you'll be looking at if you use the placement drive and they have some OA PYQs, you'll be able to see that they've directly lifted gate PYQs. So please, I stress on gate PYQs. And this link, shared by Yashi was really, really helpful. I think if you solve this whole PDF, you will, this covers, I think, 90% of what can be thrown at you in an interview. So yeah, this PDF is also very good for an interview, and gate PYQs are really good for getting through the OA. Yeah. Resume building, again, I think both Asmita and Manasvi have covered what to do on your resume. It's the same for analog or digital. Those steps remain consistent. Please, whatever you put in the project section, please be sure that you know every word of it. Like, for example, in my resume, in the project section, I put like a project on robotics I had done as part of my SOP. And the first thing the interviewer asked was, what kind of board did you use to make the robot? Was it a microprocessor or a microcontroller? And that is something that I think, like in at least Anupama ma'am's videos on MUPI, that's the first thing she goes over, the difference between a microcontroller and the other thing, what is it, microprocessor. So yeah, please like read between the lines, be okay with every detail that they can, with every nitty-gritty detail they can ask you about your project. Please be consistent with that. It looks really bad when you fumble, again, something in your project section. Again, and also at least like get an opinion on your resume from like 2 or 3 seniors you trust, because the first draft of your resume is never going to be correct. It's going to like you will tweak it. You will tweak it for 3 or 4 days, and that brings me to this point. Like, please start making your resume as early as possible. Like from now on, if you want, if you already have projects, like start thinking about, okay, like not from now on, maybe like a month before your SIP start, but you should have a rough outline. Just jot down points you want to know, because again, your resume will go through a lot of iterations. You will improve it. You're not going to have the correct one at the start. Yeah, again, I think I've covered this. Projects, like again, if you feel there's something I want to point out, like a lot of you, I think, are doing your PS1 right now, if I'm not wrong. In my interview experience, at least, the PS was really important. So if you have taken like a station like Siri or CDAC, try to do them well. if they're related to hardware like FPGAs, I think Siri gives a lot of FPGA projects. And if you're like writing Verilog code, please do it well. They will shine out. That is something that will make you stand out. So do that well. But do not, yeah. And importance of CGPA, again, like as a lot of people have stressed, it's not a like it won't disqualify you. Like just keep it high enough to get through, to get through the OA, like so that you meet the qualifying criteria. Again, like the higher the better, like for you. But a low CGPA shouldn't that shouldn't discourage you from applying. This is Masvia. Okay. Also, I'll go over a few pointers for applying for an embedded SIP. So again, like I'm not working in embedded systems, but I did prepare for an embedded SIP, and I've listed down some pointers for you guys. So you can go through them. So the first, like the important course for is obviously C programming, and CP in the first year is mostly gives you a great introduction. So again, you should have a grasp on fundamental programming concepts. Like you should know how a C program operates, like something like control flows, recursion, all of that. Uh, I've only listed basic data structure, trees, and linked lists. You do not need to go to graphs. Like that is I think that comes under like I think that's proper DSA. Like that's something you will do for IT. Yeah. And again, this is where embedded diverts from like how you prepare for an IT SIP. Because in IT, like you will mostly be looking at how algorithms behave. Here, you're interested in how C behaves, in how a programming language such as C will interact with hardware. So you should be like willing to look under the hood of C, like how it interacts with the computer system. Like if I assign a variable in C, like what C is doing, like how it is storing like that variable. Is it storing it in the stack? Is it storing it in the heap? What does the stack and heap mean to C? Because to us, memory is just memory. It is something C cooks up, the stack and the heap. So you'll have to look at that. Worry more about the basic fundamental features of C rather than using it to write complicated algorithms. This is the main point about how you should approach C and programming in general in embedded systems. Again, pointer arithmetic and bitwise operations. You should be very, very clear with how pointers behave in C. That's a very fundamental feature of the language that you will be asked. Bitwise operations are will be stressed upon because that's how mostly we interact with variables in embedded systems. If you hopefully get some experience later in life with embedded systems, you'll get what I mean. Bitwise operations are just really fast in C, and that's how we pick out certain bits in let's say a 32-bit integer. Yeah, and OS, I realize a lot of you haven't done in the second year. So I've just left these two topics, scheduling and memory management, is just something that you should know about, like what they are and how C comes into the picture. I think like a quick YouTube video search of like whatever you find approachable is good. MUPI and computer architecture is useful only for understanding how C is behaving with hardware. Assembly is, I think, very important. Like again, like you should not. I'm not saying that you should be very comfortable with writing, let's say, like an insertion sort or a bubble sort in assembly. Like you should be, but I realize that like assembly's complexity can grow really fast compared to like how simple the program is. But you should understand how assembly is behaving, how you utilize assembly to write programs, that kind of stuff. Like you should be okay with knowing how a loop is behaving in assembly, something like that. And memory structures, caches, pipelines. Yeah, this is all, again, just something that you should know about. And there's this course called ESD or Embedded System Design that you can only take after your second year because MUPI is a prereq. So if you are interested in embedded systems, and I'm talking even after the SIP because this is something you'll do after SIP, I really recommend taking this course. It's taught by Dr. Anupama, and you get a lot of hands-on experience in how to use like common boards to design your own applications. There's a really good project you get towards the end of the class that teaches you a lot. And that again, that really looks good on a resume. You'll also be taught like communication protocols like SPI and I2C that are used to communicate between embedded systems. That's really important in embedded interviews. Yeah, I think. Yeah, and I've listed some resources here. So there's this book called Beage's Guide to C that I really like. It's written in a really approachable manner, and it's something that you can read like from this like cover to cover because it's written in a really enjoyable manner. I recommend that you check it out if you like just want to get to know C better. And there's this website called India BITS, which has a lot of questions on C, like something like it'll give you a snippet of C code and ask you to predict the output, like basically what you did in C. I recommend going through this uh, because like it'll really help you understand the finer points of the language. And also, India Bix also has like questions on logical reasoning, something that Asmita mentioned. If you want to get that kind of practice, this website also has that. No, yeah, and even for the digital people, like if you want to try out for like hardware engineers, like in Google or Apple, and at least in the PYQs that are stored in the placement drive, like for Google and Apple hardware, a lot of questions on C do come. So I like you can use this link to practice. Yeah, I think I'm done. Yeah, so.
Okay, so now for all the members in the meeting, any doubts you have, I would like you to put it in the chat or in the live stream, put that in the chat as well. And those questions will be addressed by the panel. So until then, we can go through some of the questions that have already been asked. So there are some questions here with respect to the interview and asking if the interviews are difficult, and maybe you can add some points to that for each of your individual experiences.
Well, I think for the analog interview, most of the questions are repeated every year. So I have attached some links. If you watch those videos and go, and if you watch mock interviews, you get an idea about the kind of questions that are asked, because you will most probably be asked similar questions about RLC circuits. So that will really help.
Okay. Are any of the other panel members adding anything else to what Ashmita just said? Okay, then I think we'll move on to the next questions. What about those people in Phoenix that want to go into IT in the future? Is it necessary to do an SIP in the electronics field?
Yeah, I'll answer that. So I think right now you'll kind of know what you want to do. So if you're interested in IT and you feel like you've done your coursework reasonably well, you can prepare for both. Because like compared to what you have to study for an IT SIP, the portion for at least digital is not that large. There's a lot of depth required, but if you feel like you can manage both, you can give both a shot. And again, it's not compulsory to do any SIP. It's just if your SIPs are meant for people like who know what they like want to do in the future and like just want to get their foot in now, like after their third year. But yeah, you can try for both, and it's by no means compulsory. If you want to prepare for an IT SIP now, you can still sit for electronics placement. And also, like if you can prepare for embedded, you can prepare for an embedded SIP in parallel, because I feel like those two learning paths complement each other well. So yeah, that's something you can do.
Okay, thank you. We have another question asking about any topics or ideas for projects which can be completed during these 2 months. If it's possible to answer this question from the perspectives of like different year students, that would be great.
I can talk about digital. So if you have a basic grasp on Verilog, it's not that hard to design like a single cycle processor. It again, like it's a really like beginner level project as far as like digital is concerned. But I've seen it on resumes that have been accepted. So like that is something that you can try out. You can just like Google a single cycle MIPS processor, and you can design that in Verilog, synthesize it in Vivado, and see like how the circuit is looking. It's also a great learning tool. Yeah, and that's a good digital project. I think Asmita can talk about analog if there is something.
Yeah, for analog as well. So what I did during my summers was, so I was already working on an SOP, but my main job was to just research about multiple like current developments in analog. So that actually really helped because I remember they asked me a question about MOSFETs, and I added in something that I had just read on an IEEE paper randomly, and they were really impressed. So I think for analog, if you can't find a project per se to do, you can at least keep your eyes and ears open about the recent happenings and developments in the analog domain, and you can just add it in your interviews because that is actually pretty impressive for the interviewers.
Okay, so we have another question asking, apart from MUP and MUE, are any other courses in 2.2 helpful for prep in SIP?
Not necessarily. MUE and MUP are the only courses that are required. You don't essentially require a lot of SAS and conses, and you can skip it, actually. It's not required.
We have another question asking, is signals and systems important for digital roles?
Yeah, Manishwi, go ahead.
It's not really important. Like, it's very rarely asked. I don't think it's really asked. Like, it's not asked. It's not important. You can just know the basic concepts of convolution and stuff, and that also in very rare cases it won't be asked.
Okay. What should we, this is coming from the perspective of a first year student who hasn't really delved into the core subjects yet. So the question goes, what should we do as firsties to prep for SIP as we haven't studied any core subjects? Also, how to get the project that you want to do?
I think as a first year student, you can just chill, Abhi. You don't need to do anything. I started thinking about SIPs after 2-2. So and it is not, you don't need a very intensive prep, to be very honest. You can do it very easily in 2 months. Also, for to understand what project you want to do, I think the best way is to explore with multiple projects. Try to explore different domains, try an analog project, try a digital project, an embedded project, see what you like best. Now you have the time. You don't have to do all formal SOPs. You can talk to professors, see what actually interests you, and just try to work on such projects from your second year. So that will help.
Okay. So we have another question asking us about if you can give a rough approximation of of how many companies can be expected to come for both digital and when do they come?
Okay, so like as far as the number of companies is concerned in SIP, that's obviously lower than placements, and in core it is lower still. I think like for the entire core SIP, we had TI, NVIDIA, and Google hardware. Correct me if I'm wrong. So and analog only TI is the only company that hires analog engineers, and they took 2. So digital, I'm not sure of the exact number. Maybe Manasvi can tell you. And Google hardware took 2. So yeah, like I'm not gonna lie, there's not like many positions, but that shouldn't like affect your preparation. You should just like focus on the prep because it is going to come in handy, like in your placements.
Yeah, for digital also they just took 4 people. So yeah. But they came for another role. TI came from a product marketing role in which they took 3 more people. So yeah.
Okay, we have another question addressed to Shivansh and Manashvi. Can you elaborate on what exactly you are required to do in the internship?
Um, well, we just started, I at least joined on the 20th, and I'm still setting up my tools. I work in a DFT, which is again, like I told you, what happens there. We try to insert circuits that do not affect the like functional design of the hardware. Like, let's say if I'm making a circuit that's doing a Fourier transform of like an like a 8-row input, I'll try to put in some circuits that test to see it's working correctly after I've manufactured the chip. You will of course do verification you will do functional verification. That is theoretical, like you'll write test benches, but that's functional verification. You have to ensure that the chip works in real life. So that's what I do. Uh, Again, we're mostly setting up tools, and we I don't have a clear idea of what I'm supposed to do. So you can ask me that after 2 months, I guess.
Okay, great. And the rest of the panelists can also elaborate on their roles, how much ever they've worked on it so far.
Yeah, so I also just joined on 19th. Work started from 20th. What I know as of now is I'm going to design verification part. So I'm going to use System Verilog as a language and UVM framework. So what happens is the same. I'm working on basically bus protocols. So on that, we have certain interactions and interfacing thing, and the same that I would be writing some test cases and analyzing and verifying it. That's what I have right now idea, but it seems interesting.
I think there was a question on adding ML related projects as well.
Yes.
So again, okay, so you can obviously add it if it's somehow related to electronics, but if you have a standalone ML project, um, it really depends. Like if you just have a lot of space on your resume and want to add it, sure, go ahead. Because again, like ML is a thrust area in kind of all industries. Like there is like it won't harm it. Like it's fine. Like if you have nothing like that is more relevant, it's fine to add.
We have another question asking, is consistent SAS required for SIP prep?
Okay, I think we just went over.
We covered, yes.
Yeah.
So we had another question asking about how like the different experiences regarding the different companies. Like two of you here secured roles at Texas Instruments, and one of you is from Google Hardware. So do you like change your resume in specific ways, or do you change your preparation methods for specific companies, or is it more based on the role?
I think it's more based on the role. You just have a singular resume and you can like use it for all companies. It's not necessary to have multiple resumes for multiple companies. Just do it based on the role.
Yeah, like I agree with Asmita, because again, you've only just completed your second year. I don't think you have that, like, if you do, that's good, but at least I didn't have that breadth of projects to actually make different resumes for different roles. So yeah, like if you, like, it really depends on like you can obviously have digital and analog kill a different resume. If you have different projects for that, that's fine. But I doubt most of you will have it. So it's fine to have one resume.
Yeah, same. Like I cracked both like Google ka resume shot. Like I gave interview for Google Hardware as well, and yeah, I use the same resume. So you don't have to change resume based on the companies.
There is one thing I'll add. At least like in the short listings of Google Hardware, one thing that was common is like I think all of us except one, or I think all of us had a relevant PS. That was a pattern. Like all of our job titles were hardware interns or something related to core. So
Yeah, I agree with that. Yes.
yeah, so please, like, I'm not discouraging anyone who has a PS that is like, like not absolutely related to core. You should still go ahead and give it your best shot. But like, I'm just telling you that was a pattern.
Okay, I think that brings us to the end of the questions asked in the Google Meet. So thank you so much, Ashmita, Manashwi, and Shivansh, for taking the time to share your experiences and insights with us. Your journeys have not only clarified many aspects of the SIP process, but also have given us all a realistic and encouraging view of what's possible. We appreciate your openness and the knowledge you've passed on today. And to all those interested in the IT SIP talk, it'll commence at 8 p.m. right after this. And once again, thank you to all the panelists for joining us. Thank you so much.